All right, worksheet 4 kind of wraps up particle motion. So we're going to talk about speed, velocity, acceleration. We'll go through and do the first example together, and then you'll have the rest of this worksheet, so several pages there to finish for homework. So for number 1, the speed is the absolute value of, that will be velocity. If the velocity and the acceleration have the same sign, either both positive or both negative, that means your speed is increasing. That's what we looked at in worksheet 3, walking through all those scenarios. If the velocity and the acceleration are, let's say, opposite in sign, one's positive, one's negative, then the speed would decrease. And then for the next part, there are 3 ways to use an integral in the study of motion, and they're easily confused. So if I integrate velocity, this is an indefinite integral, meaning it doesn't have bounds on the end. That's where you would have an expression for, let me finish reading this, that will give you an expression for, if I integrate velocity, I would get position. So it gives you the position function at any particular time. Don't forget that you'll have a plus c, or maybe you would write a constant value that can be determined if you know the position at a particular time. You can plug in the point. For number 5, this integral, you have bounds on the ends here, so this is a definite integral. So the answer will be a number. And the number will represent the change in position of the function over whatever particular time interval. By the fundamental theorem of calculus, since v of t is the derivative of x of t, which is the position function, the integral will yield the position function evaluated at the upper bound, which is the one time, minus the other time. This is known as displacement. This answer can be positive or it can be negative, depending upon if the particle lands to the right or the left. Right, it would be positive, left it would be negative of its original starting position. Let me just slide this down just a little bit here so we can get number 6 in. And then the last one there, if I take the absolute value and integrate, still have bounds on the end. This is still a definite integral. And so the answer will be a number. The number represents the total distance, regardless of the direction. Traveled by the particle over time with an interval, the answer should always be, we're going to say, non-negative. We don't care about the direction for that. All right, so that's the first page. And then let's look at, we'll do one of these examples together, and then you're going to finish the other couple examples for homework. And these solutions are posted online for you, so you can kind of work through them using the solutions if necessary. So they give us this graph. It shows the velocity, so it's a velocity graph, of a particle moving along the x-axis from 0 to 11. It consists of a semicircle, 2 line segments. Use the graph and your knowledge of motion to answer the following questions. So let me slide this just a little bit so we can see some more of these. At what time will the speed of the particle be greatest? So if you look at the velocity graph, we don't care whether it's positive or negative. Remember, speed's the absolute value of velocity. So when t is 8, you have the largest magnitude, so it's going to be the greatest speed. Okay. And then for number 2, at the times 2, 6, and 9, what is the acceleration of the particle the greatest? Which one's going to give us the greatest value? So if I look at these 3 values, t equals 2, t equals 6, t equals 9. If I find the acceleration at those values, so I'm looking at the velocity graph, so the acceleration is going to be the slope for the tangent line. Let's try that again. So at 2, the slope for that tangent line is 0. The acceleration, at 6, over here at 6, I want the slope for this line. The slope for that line there looks like it's -3/2. And then at 9, right here, the slope for that one there is, looks like +3. So if I want to know when is the acceleration the greatest, at t equals 9, the particle's acceleration is the greatest, because the slope of the tangent line to v of t at 9 is the largest. Right, the number 3, it says which particle is the object moving to the left, and explain why. So object is moving left. That's going to happen from, it looks like 4 to 10. Because the velocity is negative. The velocity graph is below the x-axis there. It makes it negative, so that implies movement to the left. And then number 4, on what intervals is the speed of the particle decreasing? Explain your answer. So speed, we said, would be decreasing when a of t and v of t are opposites. So v of t, that's just where the graph is positioned, above or below. A of t is going to be the slope for the tangent line. So let's start in this first interval here. If I go from like 0 to 2, the velocity is positive because it's above the x-axis, and the slopes through the tangent lines there are also positive. So the same side, so the article would be speeding up there, increasing. If I look at the next little interval there from 2 to 4, the velocity is positive because it's above the x-axis, but the slopes through the line's tangent are negative. So from 2 to 4, that's one place the speed is going to be increasing. Let's look at the next interval here. So we'll look from 4 to 8 because the slope is doing the same thing at that in those values there. My slope is negative and the velocity is negative. So in that interval there, the speed is increasing at that point. All right, then the last interval there from 8 to 11. Let's go 8 to 10 because the velocity changes. 8 to 10, the slopes for the tangent line, which is acceleration, is positive. Velocity is below the x-axis though, so it's negative. So from 8 to 10, the velocity and the acceleration have opposite signs. So the speed is decreasing. All right, so that's number 4. And then number 5, they want to know what is the total distance over the time interval from 0 to 11. So I'm going to clear this out and let's see if we can kind of do this together here. So what's the total distance? So I'm going to put this one up here on the side a little bit. So we talked about total distance being the integral 0 to 11, but I can't use v of t. I would have to use absolute value of v of t. And that would give me my, my total distance that's traveled. And to find that, I can use the area. Just when I have anything that's below the x-axis, we'll make it positive. So if I integrate my first interval there, looks like that semicircle, so 1/2 pi. My radius is 2 squared. And then the next region there looks like this triangle. But again, we want total distance, so I want to make that positive. So area of a triangle is 1/2. The base looks like it goes from 4 to 10, so that would be a distance of 6. And then the height looks like it goes down to -6. We want it positive. And then the last little triangle there, 1/2, that base is 1, and that height is 3. So if I simplify this, let's see what we have. 4 times 1/2 pi, so that would be 2 pi. This would be 3 times 6 would be 18, plus 3/2. So you can leave your answer like that. You don't have to combine it together. If you want to make this 39/2, you could do that as well. But you can leave it just like that. So that was part 5. And then part 6 is find the value of the integral from 1 to 11 of v of t and explain its meaning in terms of the integral in the context of this problem. Well, that's not exactly the same answer that we just found. For number 6, I'm just going to squeeze this one right in here then, since you're working right on your paper there. So for number 6, they want to know what is just v of t. So that will take into account whether the region was above or below the x-axis. So my 2 pi part for the semicircle is fine. The next region, though, that area is below the x-axis, so I would have to subtract that 18. And then the 3/2 at the end there, that was positive. So you could leave it this way. You don't have to simplify that. And they said, what does that mean in terms of this problem? This is going to equal is the position of the particle during the interval from 0 to 11. It's going to be where the particle ends up. So final position that particle what are our units in this? Did they say? They didn't say. All right, so from t equals 0 to t equals 11. It's going to be that final position then. All right, and then let's do number 7. It's on the next page there. So number 7 says if the initial position of the particle is x of 0 equals 2, so when time is 0, the position is 2. What's the, find the position when it's 11. So they give us, let me just slide this up a little bit. So they gave us this starting point. So if I integrate from x is 0 to x is 11, that velocity function, I would have the position function evaluated for the upper bound minus the position function evaluated for the lower bound. So they gave us a different starting position than what we had. So if I want to know what x of 11 is, I could rearrange this. I could put that x of 0 on the right-hand side. And x of 0 they gave us was 2. This integral we just figured out in the last part there, we said it was 2 pi. And we wrote it, I didn't combine it together, but I did here. It was minus 33 over 2 for that one. Now you could leave it like that. If you want to simplify it and combine those two fractions together there, you'd have 2 pi minus 29 over 2. Right, so your position function there. So you're going to try example 2 and then example 3 to finish up for homework. They're pretty similar to what we did. Like I said, the solutions are posted online, so if you want to check or work with those as you move along there, that's certainly fine. The next one you can use a calculator for. The third one, example 3, looks like it's non-calculator. Usually they tell you specifically. So try to do that piece without a calculator. Make sure you finish